Alright, so we're going to do a few examples of stoichiometry since I heard some of you are having problems with this in lab. So stoichiometry is simply using chemical quantities to find out how much of a product forms or how much of a reactant was consumed or anything. But first we need to think about our basic map for stoichiometry. Usually we start with grams of A, there's grams of a given thing, and we divide by the molecular weight to convert it to moles of A, and then we convert into moles of B, and as long as we have a balanced reaction, we can convert between anything. And to convert from moles of A to moles of B, we need a mole ratio. And then last but not least, we need to get it into grams of B, and we do so by multiplying the molecular weight. And we may need various parts of this map. There's some parts we may not use. We may start with moles. Who knows? But the point is that's pretty much the whole map we need. So, okay, let's work through an example. I've got, let's say, if 5 grams, 5.00 grams CO reacts with excess oxygen, how much CO2 forms? So what I'm doing here is I'm just converting between CO and CO2. And since I said excess oxygen, that means I don't even need to worry about it. So alright, we start. First thing we do is we start with our given. We have 5 grams of CO. 1 mole is 28.01 grams. This is the molecular weight. Okay, now the next thing I need to do is to convert between moles of CO and moles of CO2. So, okay, on the top, I need what I'm going to. I've got 1 mole. Whoa, I don't have 1 mole. 2 moles of CO2 to 2 moles of CO. Now, I realize this will neutralize down to 1, but we need to do it for unit's sake. And then, last thing we need to do is convert it to grams. So we have 44 grams CO2 in 1 mole. This is the molecular weight. Okay, then we go ahead and we calculate that out. What I do is 5 divide by 28.01 and then times 44, which gives me a final answer of 7.85 grams. Okay, so I went from grams of CO to moles of CO to moles of CO2 to grams of CO2. And that's what you do with pretty much every single one. So okay, that was a simpler example. Let's go ahead and look at one where we have 2 givens and a limiting reaction. So limiting reactant, or reagent, whatever, that is the reagent or the reactant that is used up first in a reaction. RXN means reaction. You probably knew that. But okay, so let's look at a different example. So we've got, let's do, okay, so how about, let's do NaCl plus NH3 plus CO plus H2O goes to NaHCO3 and NH4Cl. This is all 1-to-1. So let's say if 100 grams NaCl, oh, still